Hi and welcome to the back of this Teardown Lab. We haven't had a Poundland item for a while, and this is the cheapest inverter you can get on the market because it's £3 in Poundland. That's probably about $4 or $5 to those over the Atlantic, and I think it represents quite good value for money. Now I know it's only 75 watts, 150 watt peak, but that's enough for quite a lot of small electronics that you might have with you if you're in your car or camper van or something. And the reason I bought it was I thought it'd quite be a nice addition to getting a leisure battery or similar, and then making your own little, you know, what do they call those, like power bank chargey station things. So I thought let's have a look inside and see what you get. First things first, there's your paper thing. It does say here 12 volts DC from converts 12 volts DC from your car cigarette lighter to 240 volts AC or 5. Oh, it's got 5 volts USB. It's got the USB as well. Crikey! And oh, it feels quite heavy. I mean, considering again £3, I don't think you can go very wrong. Now I did check this out earlier. It does say it has maximum continuous power of 75 watts, a peak power of 150, max efficiency 80%, outputs 240 volts, has thermal protection, short circuit protection, overload protection, and all the protections you need. And it says it was shaped to take the European plug as well. So good. Right, all that can go in the bin. We're not really interested anymore. And we're going to start unscrewing this bad boy. Now, like I said, the I wanted to do is to sort of test it in terms of its dismantleability so that you could fit it into an external enclosure. So first things first, that's your fuse. So if you're going to fit it and wire it to something like a leisure battery, you're going to need a fuse. And this fuse, trying to read the value of it, 240... looks like a 10 amp. It's a pretty big fuse. Now, my hope is that the PCB layout inside is somewhat sensible, because you're going to probably want to mount the electronics to a standard wall socket rather than try to use this one, because I'm not sure that's going to fit nicely. So it'd be interesting to see how much of the PCB is integrated all together. And I suspect it might be quite closely integrated, because if I was, I'm going to guess, if I was making this, I would make the contacts for the mains stuff just part of the main PCB. I am just very impressed with the weight. It is quite weighty. There's obviously some electronics in there. What will it be? Switch mode? Has to be, right? An inverter. Ooh. Okay, so I was expecting this half to separate from that half, but nope, the black bit's going first. There we go. Let's keep going. Yes, we can keep going. And we're almost there. So I was wrong on that. The panel is actually wired in a nice way that would be handy. So you've got this power LED that's coming here, which we can unplug. Zoom in again. And if we just slip it out gently, ever so gently, right. You've got your live mains wires here, and you actually have the ground is connected, the earth is connected to ground. So that'll be interesting. So these are probably floating. I don't think either of them would be referenced to that, but let's see. I mean, you never know with these things. So let's, got our continuity holding it on that. Yeah, so these will be floating. So I don't know in operation, it'd be interesting. In operation, you could measure the voltage between one of these contacts and the ground. I'm guessing you're going to see full mains. Sometimes neutral, for example, would be referenced pretty much closer to your earth, or at your earth potential, at your fuse board. So I've never really thought about inverters and how they perform in that way, and if there's any issues with it. Just be careful. Like, I'm going to give you an example. Let's just check one thing first before I do. Let's check this USB. Yeah, so the USB is okay. So I was going to say that it's more likely if you have a USB charger plugged into here, for example, and then the wire of that USB. So you got the plug, which would be referenced to Earth, same like that. If that plug touches an actual Earth, you might have something blow up. Yeah, that's my worry, because you don't know what these potentials are between them. So just be careful on that. But you'd get that anyway on any kind of thing like this. So let's have a look at the PCB. You have your input power coming in from your battery, which is reasonably heavy gauge wire. I think that's pretty good. And you have going your capacitor through this QC sticker that was just blowing my mind. Bunch of control circuitry. And then, yeah, really it's just going through a transformer, and there's a whole bunch of control circuitry. It's probably just winding that up and down. So I don't think this is using any kind of anything fantastical, really. I have to look at these part numbers to really give you any idea. Now, I won't profess I know really anything about analog electronics. I think that's been clear over the years. But I was thrown while looking at this at these strange MOSFETs on the output side. So that got me looking online, but I couldn't really find the part numbers. But interestingly enough, I believe you've got here your USB side, and then you've got your regulation for your USB power. So that's totally simple. Think of that as a totally separate thing. That's fine. You can erase that from your existence. But if you think of what's happening here, you've got an AC output, yeah, but you've got a DC in. So what can you do? So the first thing you need to do is convert your DC signal into an AC signal, because transformers only work with alternating current. So that's what I feel these guys are doing. So these are some sort of MOSFET-y devices, and they'll be being controlled by this circuitry, which will be turning them on and off rapidly to make some sort of frequency. And it could be really high frequency. It could be more higher than what you'd expect normally, even on mains potentially, right? And here you have what is the temperature sensor, and it's just basically glued on. So you don't want that falling off. Otherwise you're going to have a problem, and you could probably just have a runaway overheat there. So these are creating a signal that's going on this input side of the transformer at whatever frequency, and let's assume it's the regular mains frequencies. But then this is the bit which blows me. On the outside you've got your AC1 and AC2 on the output, but you do have 4 MOSFETs here, and you're like, well, what are they up to? So are these some sort of power conditioning MOSFETs on their output? I mean, I don't have any oscilloscope, things like that here right now, so that's really ultra annoying. But let's think about it from a teardown perspective. We want to do something with this so it can do some work. So this is very boxable. In fact, I'm pretty sure I'll have an enclosure that this can just pop straight into. So, for argument's sake, you have a choice. You could use a main style one. So this is an old consumer unit panel, or maybe one that I've harvested the breakers out of because it was cheaper to buy the whole thing from HT5. Or something like this, which is a metal project box. So as long as your height allows it to fit with suitable insulation, you could 3D print something. I mean, something I noticed here is that they left the wires really long on their capacitors and through-hole components, so I would definitely trim those back and then work out how I could mount this inside a case, because you don't have too many mounts here. So you've got these two, and you'd probably have to 3D print a bracket or something to hold that. You could potentially glue the whole lot down, but remember, you do have some mainsy stuff here. That would work better in a plastic box than a metal box. So you could shove that all in. You could put a nice fuse holder in here, one of those screw types that you pop on there, and you could just cut a hole and mount a normal domestic mains socket right there. The main problem you're going to have though is your USB, because your USB really wants to align to something, and if you align it on a metal box, I think you're going to have a pretty awful looking cut. I've really never managed to machine one of these to look good. I know it's all by hand, I've not done it with CNC, but all the marking, all of the pilot holes, everything like that, and when you do it, it still looks pretty now. So all in all, in some sort of conclusion as to the usefulness of this, I mean, if it 75 watts is all you need, and you're prepared to risk using one of these in your vehicle, I think it's worth the £3. I don't think you can go wrong at all, can you, for that money? If it doesn't work very long either, you probably don't feel that you've lost out. I had a look around. I did used to have an inverter years back, and you're talking maybe 20 years ago, and it wasn't an expensive one, it was just a cheap one in a metal can. I mean, this thing is dated 2016, so it'd be very probably similar technologies, could even be better. So get on down to Poundland and have a look for your Rockland. Let me know how you get on if you get one. Thanks for watching.